Welcome back. Today we have two presentations and then we have the award ceremony. The first presentation is by the formidable Surround Group, which is a super group consisting of three groups. I'll let them start. They will introduce each group independently as they start talking about their part. And go ahead.
So as the professor said, we are Surround, the eight of us. And so Surround, it's basically just a board game on the iPhone. And so to start off, we're just going to kind of run through how you play it and how you interact with the actual game. So to start off on this home screen here, we have you have like three different buttons. The tutorial, you can click on the tutorial here and it'll show you how to play. It's pretty cool. You can scroll down and it has a nice little tutorial there for all the stuff. And so, I mean, that's, you know, of course when you start playing the game, you're not going to know how to play the game. So, and when you click play, you have to enter a username since you're going to be communicating between two different iPhones. And you need a unique username for each person. So we'll just do my name here because everyone should know who I am. And so this is the board right here. It's just a bunch of hexagons. You can zoom in and out. Click. Or you zoom in and you can pan around on the board like that. So to start off with, we can choose a piece. And since we're player one, we have two different choices of colors, red and yellow. We can click on yellow here, and it gives you your piece choices, but we'll go back because yellow is hard to see. We'll go to red. And so all of these letters here, they represent a different piece. So for example, if we click on C here, you can see it's in the shape of a C. And you can rotate it around. You can click it really fast, it rotates pretty quickly. And so since we have it oriented like that, you can click right there and it'll place the piece in the shape of a C in the way that it's oriented. And then we can go back, and you can actually check the pieces that you have left here. So you can see usually there's 3 C pieces, and since we used one already, it subtracted one, and I accidentally clicked one of the line pieces over there, so I subtracted one of those as well. And then there is a network function, but we can't show it between two iPhones right now since it's on the simulator on the actual iPhone here. And so, okay, so I just clicked pass button. And so what that does is it'll just finish the game and tell you like which pieces or which hexes here have ownership from red. And so this is like if the game was finished already. And the dots show where ownership are, and you can see that because no other pieces have been placed on the board, if you only have one piece on it, you have a majority for that hexagon. And so the pieces that have a hexagon on them, they have ownership of red. And so if we had another piece of color on there, it would, it might be contested, or it might be a different color, but we can't show that since we don't have another player right now. And so that's pretty much the game board right now. We're going to get in the presentation, which will actually show what some of the complexity and what we had to do to actually get the game running as it is right now. I guess we can get into that. There it is. Woo. Okay. So, it's a presentation. So, Surround. We're Surround, like we introduced. So basically, the entire game is hexagons, and you can see the different teams down here. We'll introduce the teams as we go down the slides, but there's 8 of us, and these are different teams. If you want to see. Oop, okay. So yeah, so like Surround, it's an iPhone app, like we said, only between 2 people. You can play it over 2 iPhones. You can have multiple games in progress. That's something we haven't implemented yet, but it's something that is going to make it into the final game. And we also have a message service that you can talk between 2 people. We obviously can't show that either because you can't play with 2 people yet. So yeah, we're going to talk about the user interface design a little bit.
So I'm part of the user interface team. I'm Mcclendon. Also part of the user interface team is Will Sampson and Patrick Abel. So as the user interface team, we had to come up with designs for the actual game and all the other screens for it, as well as implementing them. So as one of the first things we did was think of how to do the board and actually learn quartz, which is the drawing mechanism which we use to actually draw the lines and such for the board game itself. And then the next thing we did was we learned some interface builder for the other menus, like the login screen and the splash screen, which the splash screen also uses a PNG picture to just display a picture to make it look pretty. So, and then moving on, we have buttons. You hit play, as said, and then you go down through the different views. And then we also handle some user input with how to press which button, and also clicking on the screen and get touches for that.
Okay, so my name is Anthony, part of the engine team. The other members are Steve and Ashley over there. So what the engine is it's the back end to the user interface. It is what handles like keeping track of all the different statistics of the game, like scores and all that. Actually setting up the functionality of the board, so we're storing like where the colors are and what color owns what hexagons. And we're also like obviously having to implement the rules, like when the user interface, when they select certain lines to send down, we have to validate that and let them know if the validation was right or not, or if the move was right or not. And so the user would pick again. We're also sending data down to the network team, who will talk in just a moment, and they will end up passing the stuff sent down to the other opponent's phone. So kind of to just describe like how we're representing this whole game is we have a 3-class system. There's a board class, a line class, and a hex class. And the board, like a line is just obviously like one side of the hexagon, like what color owns it and what direction it might be facing or whatever. A hexagon, we want to know if the color owns it, if they have a grand ownership, which is a technical term for like if one color has all 6 sides to it. And so using an array of lines to kind of form the grid that you saw in the demonstration, we're able to take all the lines, take all the hexes, and combine them in the board with hexes having references to specific lines, for instance. And then when a move is, as I said before, when a move has been validated, it'll go back to be redisplayed for the current user. And part of how we capture the move was the user interface. When they draw the lines, there's no actual touching component to them. They're not buttons or anything like that. So there was a field created, like a field of kind of like an overlaying grid. And it logs where a click is touched relative to the screen, and using like the pixel coordinates from where it was clicked, it'll find the nearest line, and then that's the move that'll be passed down to us for validation.
All right, my name is Brian McWilliams, and this is David Albert, and together we make up the networking team. Now, the main goal of our aspect of the project is to allow a game to be played between 2 users on 2 separate iPhones. And to do this, we created an Oracle database, and to which users send their information stored. Other users get that information. And we also created an instant messenger service, which includes a profanity filter. And that's just so users can speak with their opponents And much of the game data is stored persistently on the server, including information about registered users, their approximate ratings as to how good they are in the game. Now, the basic network structure is one iPhone sends its information, that gets processed by PHP, and the query is sent to the database. The data is stored until another phone requests it, at which point the server sends it out.
Alright, so I'm Steven from the Initiative team. I'm discussing our major challenge, which is when a player is trying to click a line, they're going to touch the screen, and that point won't have anything to do with anything we're trying to do. And so clearly there's a draw path for a hexagon somewhere on the screen. And so based off where a user would touch, it'd give us their pixel location. But then we'd have to find the pixel location of the nearest point of our hex. So we'd have to run this search to actually find the hex based off a user's touch. But even then, that pixel location on the what the screen is has nothing to do with the board underneath where the rules are. So even after we found this hexagon location from a user touch, we'd have to then go to the board and find out where that is on the board and actually connect and translate this user's touch location to where we want it on the board and the line that relates to it. And then even after we found that line, we would have to actually span out, and based off what piece the user is using, what other lines also need to be selected and have their color changed. And so it was this very complex process, involved us using multiple arrays with multiple location points to get this all hooked up.
One of the main challenges that we faced was getting the network ready to have many iPhones connecting to the database at once and not having any of their actions interfere with anybody else's. And we chose Oracle because it's good at handling many concurrent users at once. And then another challenge we had was just getting familiar with Objective-C, PHP, and PLSQL, the Oracle's procedural language, and handling error situations between those and user inputs. And finally, as you can see, we have a pretty large group. A big challenge was organizing everyone so we could meet and integrating the aspects of our project.
Yeah, unfortunately, the availability to actually work on the code itself was limited by the platform we're on, like Mac operating system. We're using Xcode programs like Codal's Objective-C stuff, and we can only go on Mac computers for this. Orchestrating that between 8 people who don't have Macs is kind of hard.
Questions?
Any questions from anyone?
When will this game be available for the
Oh, that's a different issue entirely. People who own the board aren't us, and so we have to actually get into what that entails, and so that's a whole business that we have not discussed yet.
Yeah, I mean, hopefully we could probably make some money off of this game if we put it out there. But again, we didn't actually create the game itself. We just made it for the guy who created the game.
So has he seen your product, and what does he think of it?
They've seen it in the early stages. They have not seen it in the current stages, so
Yeah.
we have yet to re-show it to them.
We just finished it last night, so so he hasn't quite seen it yet.
Did you guys have to have an Oracle license, or was there a trial version? Or it's expensive, isn't it?
The school has it. So I'll bring it up there separate.
It's one of the perks of being a Sonoma State student.
Nice. Okay.
All right, so that's it. We're around. Thank you.
Thank you so much.
Great job. Great job.
Good job, Ashley.
Yeah. Apparently.
Help yourself. Christopher for taking the time from her busy schedule to come here. We really appreciate it. Thank you.
Here. The good old days.
Good old days. Of course, I want to remind everybody, and I want Dr. Christopher to hear it, that she's still the faculty of Computer Science Department. So our next talk is by three of our students who have worked with Dr. Ravi Kumar on a independent project, Michael Harris, Nick Hughes, and Casey Blair. The topic of the talk is Schedule Optimizer. And if you could give some background to it, that'd be great. Thank you.
So the program that we're making is basically to take student input from, well, we just figured we start off with computer science students, branch out from there, of what classes they want to take in the next semester. And then the professors will put in all of the classes that they're going to offer, and it will optimize a schedule that has the minimal conflicts. And so, the reason I'm doing that is because next semester there were like a bunch of classes that were all at the same time, and I was like, there's got to be a better way to do this. So we started working on this project. And so the algorithm that I made up to create the schedule is fairly brute force, but not completely. So basically what I did was put in the schedules or put in the classes onto the schedule, and then scored each conflict based on how many students were in each class that was at the same time, and then started just rearranging them until an optimal schedule was reached. And so then we have Casey, who worked on the user interface.
Yeah, to take input from the user. We set up a PHP supply some website, and it takes your email address, your CWOP account email address, as your user ID. And so if you have to have CWOP in the account name to sign up. And so you pick out your classes, and then we get sent, your choices get sent to the database with priority for which one you want to take the most, down to the least. I think we allow 10 classes. Yeah, and so it takes that, sends it to your users table. And when you want to call the C++ program, it would take a bunch of queries from the database and it dumps into the text file. And then that text file gets passed to the C++ program as a parameter. And it runs its program and sends the output to the screen, which PHP takes and puts it back up on our website. So you can see which class is most popular, all that kind of stuff.
And I set up the database. It's like the last group was talking about. We use Oracle because it supports a lot of users, and we can keep the data pretty securely on there. A big thing that we made sure of is, like Casey said, the user ID is a CWolf account name, and that's about the most sensitive information that's on the server. So if someone actually did get onto the server, because we're not great on the security side right now, they're not going to find anything important in there. The biggest thing that we had to keep in mind, at least for me, when I was designing the database, was that we're not storing the classes that students are taking. We're not setting up the schedule for them. We're simply storing potential classes, what times they can be, professors and students, and like what classes they could be taking or what they want to be taking. We're not setting up any of the schedules. Ultimately, the professors will take the input from this and they can take it or leave it. But they will, take the classes, and then the students have to sign up for the classes themselves. So we're not storing any information about student passwords or ID numbers or what their schedules are or anything about even paying for classes, anything like that. We just have one table for users, which will have both teachers and students. We just have some Boolean values that we can check whether they are a professor or not, depending on whether they can change what time a class will start. That's obviously, if you're a professor, you can do that. If you're a student, we don't want students being able to mess with that. And then we have the class table, which is just each specific class. And this one took a lot of collaboration between all three of us to figure out what we wanted in it, because there's a lot more variables for setting up a class than you'd expect. I mean, for instance, we just have the class number, which is easily identifiable for the class. a name, a description, the teacher. That's how we know which teachers are for the classes. Then for instance, type. We have D, L, A, and B, which means there was discussion, lab. What were the last two?
Lecture and activity.
Lecture and activity. You don't consider that when you're signing up for class, but that's actually, there's 4 different types of classes. So we had to make sure that, if we have a lab and a discussion together, we have to actually think of it as 2 separate classes, because we don't want to have a bunch of classes with a bunch of extra variables that we don't use in case it's not a lab, so it doesn't need any of the lab variables. So we had to make sure we had a type for that, and then we have requires, which will tell us whether it requires a discussion or lab connected to it. Allowed start, I believe, didn't go over that too much with Michael, but I'm pretty sure that's about like what time during the day it can start. It's in half an hour increments. We just have like a string of zeros and ones. Ones for when we think we can have the class, zeros for when we can't. That once again goes into his algorithm and helps us plan when the classes can be. Start hour, start minute will be like tentative, pretty much perpetually. Whether we think we're pretty sure this is when it'll start, so students can see, oh, looks like this class will probably be at this time, and they can check for, according to their schedule. But of course, this is always probably going to be changing as students add more data. Num blocks, once again, that was for his algorithm. As simply, we thought of the classes as half-an-hour chunks, because it's a lot easier to schedule classes if they're just in blocks, rather than thinking of it as, oh, it's an hour and 15-minute class. It's just 3 half-an-hour blocks. And then you just chunk out data like that, because it allows room for breaks as well. And then we have things like num days, number of days of the week, and then num days is just days during the week, C 0 to 8. And then days of week being Monday through Friday, Monday through Sunday, I guess. Day times, meaning morning, afternoon, or evening classes. And then can change being whether this really is a set in stone class. If it can't change, we're going to have that as 0. So that this class is going to be at this time one way or the other, so students will know. And then finally will be the students in classes table, and that's specifically just to link students to classes that they want to take, so we can find out for his algorithm how many classes or how many students want to be in a specific class, or like what priority. Like if a class has 1 student in it, obviously a class with 50 students in it will have a lot higher priority. And this will be where we store all of our data, and that's about it.
Questions? Any questions? So you guys actually have it's something that you can show us right now about how it works?
You have output maybe?
Did you get any output?
Well, I have the output in a text file.
Yeah.
Yeah, anyway, like a schedule or something.
Yeah, because we've been using test data, and it's been somewhat successful.
So, the input text file that the C++ program reads looks sort of like this. And so, it's kind of messy, but here's the allowed times. So you can see, short range of times, then break at noon, another short range of times, that sort of thing. And then the output is basically just a list of classes. Here's which days they'd be on, and the starting time based on the half-hour block. So 20 would mean 10 o'clock.
So the one nearest to the top would be the best selection of the one you'd want to have.
The order they're sorted in is just the order that they came out of the vector.
Right.
So the user interface is just resorted according to department or any other. They're sorted based on number of conflicts. So those with the most conflicts are at the top.
Right. You could also see which class is most popular by how many people and what priority.
So if any of you are interested in providing test data for us to use over the summer, at some point in the next couple of weeks we'll probably have the website up, and we'd love more test data.
Thank you very much. All right, so moving to the second phase of today's schedule. We have 3 different types of awards today, one for the Computer Science Club students and one for WICS, and the Distinction Awards. So the Computer Science Club. The Computer Science Club plays a very central role in our program. they kind of provide what we don't. We provide support for the classroom, and they provide support for the students outside of the classroom. They kind of provide the bridge between students and us. Not that students don't talk to us, they do, but kind of a more generalized types of information. They provide different services for students. They bring different people to give presentations by different people from different companies, or host resume writing workshops. So we really appreciate their support. We appreciate the work that they do for us. And this year's president of the club is Eric Miller. Thank you. Thank you.
Okay.
You can.
What do we do?
And the Chris Walker.
Walker. It's like Walker without an L.
And she's never corrected me. The vice president of the club. Fred Wong, the secretary of the club. Anthony Cavallero, the club treasurer. Thank you, Anthony. And William Sampson, the finance. Thank you. All right. Can I now ask everybody who just got an award to come here and take a picture with the faculty? Maybe we'll keep you here next time.
Should we stand?
Oh.
You got to get in a little.
1, 2,
3. All right, got everyone.
All right.
Women in Computer Science, WICS, so I'm going to say WICS is a chapter of the National Women in Computer Science Organization. It's an organization that is designed to help support women as they go through both being a student and a professional in computer science. It helps to support men too, and actually has become quite an active social organization. They've organized a number of things over the last year, including last Friday was it? Yeah. We had, when you're on sabbatical, you lose track of the days. We had our annual social, and Dr. Stauffer very generously opened her house. I think there were about 15 of us there, maybe a few more than that. About half men and half women, so if you're a male, don't feel that you don't belong. This year's officers, President Stephanie, is she here?
No.
Stephanie Schmidt?
She has a class.
Oh, she has a class right now. Okay. Vice President Carissa Walker. Congratulations. And Treasurer is Leslie Prince.
That's what it is.
Thank you.
All right.
So thank you very much, and we'll let you take a picture.
We should do Crossfire.
Crossfire.
Dr. Ludin, you gotta get in the.
Alright, got one, two, three. Wait. Alright.
So the next award is graduation with distinction. And we're proud of all of our students. We really value every one of our students. And of course, we award those students who excel in our program. And it's this semester, we have 5 students who were awarded graduation with distinction. And the requirement for this graduation with distinction is 1 GPA of 3.0 or higher, and the ability to internalize information. Really, courses that we teach, each one of them is independent. The ability to pull them all together and transcend each one course and pull it together into a discipline, into a program. And finally, to have contributed to the life of the department in activities such as programming contest, such as membership in the clubs, actually being officers of different clubs. So we honor them, and we have 5, like I said, this year, and Anthony Cavallero is our first. Please come here and take a picture with us, and then stay right here so that. Ted Champ. William Malani. Eric Miller. Jeffrey Nyan. So, one of Thank you.
Take a picture of the graduation.
We will go outside for that purpose. Is that
put on
what you?
commencement.
We will. So that's okay. No, absolutely. So a couple of announcements. One is the CS courses enrollment. Thank you very much, colleagues. CS, the enrollments in our different CS courses. I want to mention to you, I know that many of you sign up for courses that are you need for your GE and also fill up quickly and kind of put computer science courses behind. I want to encourage you now to sign up for computer science courses so that they do not get canceled because of under-enrollment. Please keep that in mind. CRA survey. This is Computer Research Associates, the survey that those of you who are graduating this semester and also this summer, you've been sent a survey, you know who you are, and we only have so far 4 of you haven't filled out this survey. I want to urge you to, if you haven't done so, please go ahead and fill out this survey. We will, on the graduation day, gather in front of Darwin to take a picture of all graduates and faculty. Please be sure to come there for that picture.
At what time? Like before?
After. Yes, I would think that that's perhaps a better time afterwards. Basically, it's harder to tell when people come. But afterwards, everybody's here, so please just walk as usual, walk through the crowd, and eventually, as kind of quickly as you can, please gather in front of Darwin for a picture. Thank you so much. I appreciate you coming.